I'm Eleanor.
Hi, I'm Jessica.
Hi, I'm Louisa.
And today we're going to show you our model that we made of the thoracic cavity, the lungs, and the diaphragm.
So the thoracic cavity is composed of the rib cage and the diaphragm.
The rib cage is composed of the ribs, the sternum, the costal cartilages, and the pectoral girdle. There are 12 pairs of ribs, 10 of which are directly or indirectly connected to the sternum by costal cartilage. Rib pairs 1 through 7 are true ribs, which attach directly to the sternum. Rib pairs 8 through 12 are false ribs, which do not attach directly to the sternum. Rib pairs 8, 9, and 10 connect indirectly to the sternum, and rib pairs 11 and 12 are called floating ribs because they only attach to the vertebrae and not to the sternum. The pectoral girdle is also part of the rib cage. The pectoral girdle is the name for the collarbones and the shoulder blades. 2 clavicles, or collarbones, lie ventral to the ribs, where they attach medially to the sternum and laterally to the scapula. The 2 scapula lie dorsal to the ribs. From this aspect, we can also see another component of the rib cage, the spine. You can see that all 12 of the ribs attach posteriorly to the 12 thoracic vertebrae. Finally, we can identify 3 parts of the sternum: the manubrium, the body, and the xiphoid process. And that's the rib cage.
So here you can see the trachea, which is the most superior part of the pulmonary apparatus, which is composed of the lungs, the bronchial tree, and the alveoli. The trachea is made of rings of cartilage which are open posteriorly and connected by smooth muscle, and covered by a mucous membrane. If we look down into the thoracic cavity, we can see where the trachea splits into 2 branches. These 2 branches are called the primary bronchi, and one goes into each lung, where it continues to divide into smaller and smaller bronchi, eventually terminating at an alveolus. You can see the left and right lungs as well. The right lung is larger and has 3 lobes, and the left lung is smaller to make room for the heart and has 2 lobes.
Finally, you can see the diaphragm, which forms the floor of the thoracic cavity. The diaphragm is shaped like an upside-down dome when it's relaxed and flattens out when it contracts. You can see here the central tendon, which is what attaches the diaphragm to itself. Boyle's law states that as volume increases, pressure decreases. So when the diaphragm contracts, it makes the pressure inside the lungs, the alveolar pressure, more negative than atmospheric pressure outside the lungs, causing air to flow into the lungs. Then when the diaphragm relaxes, it domes back upwards, reversing the process. The volume of the thoracic cavity decreases, and the alveolar pressure increases, making the alveolar pressure more positive than the atmospheric pressure, causing air to flow out of the lungs.
So here's our model. We hope you all enjoyed it, and here's our gift to you, Dr. Evans.